Hello and welcome, RCSchim in the hangar. Today I will show you the contents of this box, which are 3DMakerPro Max LIDAR scanner. Full disclosure, Eagle Pro contacted me and sent me this device. I think I can keep it, I am not sure. They have no input on my videos. They sent me some contents. They helped me understand the device. This is a really early device, so the software is in alpha state. This is my first LiDAR scanner, but I think I caught their attention by reviewing the competition's Creality Raptor scanner I also reviewed. If you haven't seen it, check it out. So this is an early look on this device, and I will also have a blog post. Find the link in my video description. I had enough time to play around with this and to learn the device, and I also gave him lots of feedback, test scans, and sent material back. They will also offer an online service where they do the hard work. So you just do the scan, send them your files, and they will improve the scan quality, will work on the scan to give you a finished result. So let's jump into this video. It will have chapter marks. If it's too boring, you can skip around, but I try my best to make it quick, concise, and informative. If you don't know my channel, consider subscribing already. It will pay off. Okay, it comes very nicely protected in this Pelican style case. You have your usual power adapters for US and UK markets, EU plug, 165 watt GAN charger, the good new chargers, two USB-C, USB-C to C. On the device you have power is for charging. Data is not to connect it to your laptop to have like a mass storage interface. No, plug in your USB stick, and this way you can transfer files from the internal memory to a USB stick. This is a slow export method. I do not recommend using this. The device also has an SD card on the bottom, and if it's inserted and if it is NTSC formatted, that also goes for the USB stick. They need to be NTSC, not FAT32, not exFAT. Storage card in there. The device will automatically store the scans on the SD card, and then you can just take out the SD card, put it in your card reader, and skip the boring and long export task. Tripod adapter plate, and it snaps in place. What I added myself is this little tripod feet, and with this tiny feet, it's not a safe stand, but it's what I've used so far. Of course you can use, or you should use, a larger tripod. We can go through the specs together. It has a quite large 12,000 milliamp battery pack, works for around 1 hour. You shouldn't scan longer than 4 minutes for one scan, because otherwise the data gets too big and it makes problems. It's 11.5 centimeters by 18 centimeters by 10.7 centimeters. Has around 1.5 kilograms. That's important if you plan to mount this on your drone. It has to be a larger drone than some of those commercial grade DJI drones. And there's then an adapter to mount it upside down. And then it's way easier to fly over locations and get good scan data. The most astounding fact about this LiDAR scanner is really the price point and the entry into this market, which is such an affordable device. Because if you look up the competition, which is $10,000 or $30,000 out of reach for most, the screen size is 3.5 inches. It is said to have Wi-Fi 5. I couldn't use Wi-Fi, so it's just on papers. LiDAR. It's a rotating laser that sends out dots, and the reflection of the dots is measured. This way you get really laser accurate representation of your surrounding. 3D point cloud, up to 200,000 of these measurement points per second. And in addition, you have 4 of those 180 degree 48 megapixel cams. They call them 48 megapixels, but when I inspected the images, they were 12 megapixel. Get one in the front. That's the only one that's used at the moment for coloring the point cloud. You have one on top and 2 facing 120 degrees to the back. Up there is a SMA connector, so an antenna connector. Mount an external GPS or RTK or something like this. Pushing this button, you turn it on, and you're already here. It's quite loud. The diesel sound it makes is already the LiDAR, so the LiDAR always rotates. Then it also has a fan. Quick tour about the user interface, which feels quite alpha, and also the screen is not the most responsive. especially up here in the edges. There are some batch settings if you have more than one scan and want to export it or delete it. Before the scan there's this important exposure button. Decide between indoor and outdoor, of course. And on bright sunny days, choose between strong, medium and weak, which I think is the ISO settings. Can use this slider to adjust brightness and white balance. And once you're happy with how the image looks, it's just for the display while scanning, and then you hit scan. We have GPS. I would not suggest using spaces or special characters in the file name, and you can decide between continuous, which means you walk around, or fixed point, which means tripod mode. Currently I could use fixed point, save, and now it scans, and you see how the scan get dense because it scans a lot, and if you press it again it will stop. And this is what he scanned in the short amount. It's my room, but it gives you a good idea if it worked or not. So this is how easy you can have a scan on your device. Okay, so that's me filming with this gigantic camera. It's a bit hard, one-handed actually. And I only got maximum 5 minutes, so I gotta hurry up. Scan this fancy monument there. You should wait 3 seconds or so and then start walking, and yeah, don't make the scans too long. So the display could be a bit brighter. Here in the shade it should work. So it's magic how the object appears in front of you. Let's try to also get the statues. Move slow and steady. Oh, this is gonna be awesome. And after you finish the scan, you can look at it, some kind of detail to see if your scan worked well enough or not. Hit save, and now I have a lot of files saved. For my biggest scene, which was our castle here, I scanned 5 or 6 individual scans and manually aligned them. I ended up with 80 million points in my point cloud. And then you need a really good PC to display this amount of data. If you start scanning this way, this will be the baseline, and then you have to tilt the point cloud in software to align with the other point cloud. Always start scanning in a horizontal pane. As I said, I will have a lot of tips in the written article. The point measurements with LIDAR technology, this is where it vastly differs from photogrammetry. So if you use your normal drone and just make images and have a clever software that can produce what's called structure from motion, where it uses the difference between single shots and calculates a 3D model. This is always a calculation and an estimation and will never be really accurate.
Taken with a DJI drone, not with photogrammetry in mind. You rather take single pictures with a perfect circle and not like me circling around. But even from this footage here, which is high res but not ideal, I got this good of a model out of it with a test version of a quite expensive, what's it called? I will have it linked. And first I thought, okay, it has its flaws. This tower here should for sure be a square, but it's not. It's really that's cute. So for taking or for creating a large scale model of a scenery with a castle in it or something similar, photogrammetry might be the way easier approach. And here I didn't use the textures, but of course it comes with good textures and you don't need specific hardware other than your drone, but you invest a bit more in the software.
It looks really cool for the eye and it makes for really nice 3D models, but with a LiDAR scanner you really make a million of measurements, single laser measurements, and get a point in space back. And you can really measure in the software distances with an accuracy of around 2 centimeters. And with the point cloud, you can do a lot of interesting stuff. For example, you can also use the point cloud and convert it to a mesh. If you have a mesh, it's easier to get an object out of it. And then there's this completely different and hard to understand method of Gaussian splatting. So this is a LIDAR scan from 3DMakerPro. Those are little representations of probabilities. The closer you look to the ground, the more it dissolves into clouds. But if you have a certain distance, it looks really photorealistic. If we go through at those tiles there, and most impressively all the leaves on the trees, you see how they dissolve, but it's really cool and modern way to get a representation of 3-dimensional captures, scans. If we leave the scenery a bit, I mean here the lake looks really good, but if you look into angles that haven't been scanned, it's just black void. You can also do Gaussian splats with your mobile phone if you just make a movie and extract the frames, but it's so tedious work. I tried it and I failed by installing the software on my PC, and it's too early for the mass market, I think. 3DMakerPro, they are working on this and they try to make it accessible for the consumer as well. They will have it on their portal and you will just upload your scan there and they will do all the magic in the background and supply a finished scenery for you. It looks like a subscription model where you pay 10 or 20 bucks a month to have an account there and have your Gaussian splats there. Gaussian splatting also works with just images from your mobile phone, but then it's really hard to get structure from motion information. And they make a combination of LIDAR scanned point clouds with images taken. And if you have both the exact measurement and the color images, the generation of the Gaussian splat is faster and easier. On my scans, the point clouds, the colorization of points with the camera didn't work that well.
Most of the times I just used the white version with the shader on it.
Most of the images are kinda unsharp or not really usable, and maybe that's why my scans haven't been the greatest.
Overexposed here. It is kinda okay in the dark areas. It's underexposed, and in the sun it's overexposed again. Underexposed in here. Shouldn't it expose on its own? First it looks okay-ish, but yeah, the textures are skewed. I was too erratic in my movements while scanning and while capturing this, but yeah, this doesn't look as good as this Unreal Engine golden texture around the quite nice mesh that I got out of it.
I think you have to walk very slow and steady with this to get good images, and it also has to be like sunshine, and then it works better. So let's quickly head up to the PC with the Ray Studio.
Version 1. And it also runs this DOS prompt. And don't ignore this, because this will give you a lot of status information where the main program isn't. So if you don't really name it, this is what your scans look like when copied from the SD card. You have an image and a LIDAR back file. Those are the larger files. LIDAR is the point cloud data and image is the combination of all the photos zipped or compressed in some way. The main task of the Ray Studio is to extract these two files into usable format, and then we continue in another software. So let me show you how we accomplish this. We say we create a new project, and it's important to go inside the scan folder to create your new project and say select folder. Then in the second step, you can just make any ini file. I choose a good name so I recognize what the scan was about. And this is the first step. So we are set up and now we can solve it. So solving is the first step. And it's important that you don't mess up your back files. The first one is the LIDAR. So LIDAR. And the second one is the images.bag. This is a quite time-consuming task, and I already did it, so I will leave this out. And if you're really just for the point cloud data, you don't need the image bag file, other than you want it to be colorized. For most of my scans, I didn't touch these things because I don't know what I'm doing. When you hit apply, it will resolve or extract the LiDAR bag file. DOS prompt style, you see the progress better. You see we are at almost done with 91%. You see it now generates the AMAP file. And it will also load this. The recalculate result AMAP is the point cloud. You can scroll in with the scroll wheel. And you see sometimes this navigation makes me freak out a bit, because I never get it straight. This is a rough browser, and now you see you have a lot of points quite outside of our scan range because it has a good range. And if you want to filter out seemingly unnecessary data, you can do it directly here in the software, or you use something like Cloud Compare, which offers the same functionality. So if I want to filter, the input needs to be the output of the last step. So here I should select the AMAP file, and I will use this recalculate result, say open. Once again, I don't change any values here because I don't know what they do. Hit apply. My CPU is rarely used, like 18 to 20%. Ignore the GPU usage, that's probably just my screen recording. Normally I don't see any usage there. It could be faster if it was more optimized. So it finished another file, which is not that's the same as before. But over here you see you have a filtering result which is hidden. You see the amount of data has been limited. Maybe it removed too much of your data. Initial scan data was 320 meg and the filtered one is 200. And maybe you just want to remove what you know is unnecessary, like I could draw a line here and remove these points myself. But if you have a really large scan and want to do it with the software, you can do it with filtering. With sampling, you can further reduce the size. But yeah, I really want to keep this video a bit shorter and don't go into the detailed steps. This is further reduction. These normals are used for the mesh. Here you can color it. On coloring, you have to open this filter result as our input cloud. And you also need to select an image folder. And as I said, the extraction of images is also a time-consuming task, which I saved in the solve section, but I already have it here, images, and currently you always take the front cam. And then you would just apply. The result is a colored representation. Why not doing it? Here it knows the number of images to process, so we actually get a percentage bar, which is nice. Okay, looks like we're done. So now we have this all color PCD. And this gives us the color point representation. Yeah, if you increase the point size, it looks a bit more dense. Here is a pavilion with roof tiles, and they look kinda right. Of course, I couldn't scan the upper regions of this roof. But you get the idea. There's grass, there's a wall. That's the colorized point cloud. And it didn't work too bad here. Used the results, these .las files, the filtered result. I think here, here in shading you get these colorized point clouds. This all color, which is 200 megs large. To my surprise, I found Cloud Compare freeware to be able to even understand not only the .las files, but also these all-color PCD files. And in here, I mean, it also has a learning curve, but in here you can do way more. Let's just start with the PCD file, throw it in there. You see it even renders it better. There is this first-person mode. Here we now see that this wall is 8.8 meters high. This software is amazing, it's for free. If you have the time, dive into it, use my example point clouds if you don't have a LIDAR scanner already, and see what you can get out of it. I will have download links to my example point clouds like this one here, so you can check it out for yourself.
Okay, by now you should have enough information about this device to see if this is something for you, for your small business maybe, if it is sufficient enough. If you still have some open questions, leave them in the comments below. I do my best to answer them. I hope it wasn't too extensive. For my part though, I did about 2 months of research for this thing, but I was really curious about the tech involved here and I learned a lot. So make sure to check out my written article with lots of links and informations that I gathered. Maybe it helps you. I encourage you to check out my demo files that I linked below. So you can check out the point clouds that this thing did. They are not made more beautiful than they are. I didn't filter. I mean, yes, I filtered them with what the software provided in terms of reducing the points, the unnecessary points. But there was no softening or no polishing of the meshes of the surfaces to make them look better than they are. So this is true and honest footage that you get from it. It's exciting to see such companies reaching out to my experience, to my expertise of reviewing tech stuff. I hope I can continue this in this year of 2025. If you found this channel today, please consider subscribing. And if you want to further support my efforts in dedicating a lot of time towards these things, check out my Patreon and become a supporter of my channel. Thanks, very much appreciated. Okay, thanks a lot for watching. See you next time. Bye for now.